start. We go on Excalibur. What is the first question? I misread it. Very bad. But okay. So the first question states I am given a range from L to R. And in this given range, I can remove an element if it has k of its factors in the given range only. So if I have a 1, then how many factors of 1 are there in this range? So there's 1, there's 2, there's 3, there's 4, and there's 5. There's 5 factors, right? The number of factors of 2 are 4. So in a given range LR, how many number of factors of L exist? That is R upon L, basically, right? A factor of, multiples of L, not factors, multiples. A multiple of L will always be greater than L, right? So we just need to check how many times my L is coming inside of this R. So the number of multiples of a number in a given range, like basically till a certain number, is R upon that number floored, right? So if you see that this thing is a proper function which is monotonic in nature. What do I mean by a function? That the first element will always have the highest number of multiples. The second element will have even lesser or equal to. It won't be greater than the first element. Now, why is this so? Just think of this. I have an R upon L and I have an R upon L plus 1, right? So, for this thing, R upon L, it has some value equal to X, right? Now, if I increase the denominator, the value of my fraction decreases. The numerator is still the same. So this fraction is obviously less. So that is why I can easily say that this will either be equal or it will decrease, or be equal or decrease. This is how it will be. And there will come a point where it has k k multiples at most. This is some k plus 1, and here let's say it's k minus 1. So there will come a point where it has k multiples exactly. So this point is binary searchable. Now you can use binary search to get this point. Now if you don't know what binary search is, let me explain just once. You have a left pointer and you have a right pointer. You just go to the center. Let's say this is the center somewhat, and you are like you just go to the center number and you check the number of factors. Oh, okay, this number of factors is k. Now anything ahead of this thing is going to have less multiples than whatever I have here, and anything behind this thing so I reach somewhere here, I know anything here is going to be greater than that. Now this value is probably greater than k. That means I'll have to go ahead. So I'll push my left here and right here similarly. So stuff like this is a very crude way to understand binary search, but yes, this is what binary search is. Now coming to the code, we can just take input of LR, and I'm doing a half value. If the number of multiples at a point which I had told you, if in, let's say, we have something like this and this and this and this, stuff like this. So if the, and we reached somewhere here, our half value, if the number of multiples at half is greater than or equal to k, and my k is, let's say, somewhere here, this is my k value. So if this is greater, this thing is greater than or equal to k, exactly. So I can just not see anything that was over here. There is no need for me to check. So I just move my pointer ahead, my left pointer to the half. And if it is less than k, somewhere here, this is obviously less than k. I don't want to consider this value. So I just, and I don't need to see anything ahead. So I just go here. So this becomes my new range now. And we again continue this way. And the time complexity of this is log n with the base 2, obviously. But yeah, because we are just halving whatever search space we have every time. Okay. So this was it. Any doubts in the first problem? Hello. This is what you call binary search.
There is also one solution.
There is a
O of one solution.
math solution. You have a math solution.
Yes.
Correct.
I mean, it is just r by k minus l minus 1. That's it.
R by K.
फ्लोर का सिंबल डाल जाएगा ताकि
हाँ हाँ हाँ.
R by K will not
minus and brackets में l minus 1.
Yes.
Yes. This is math way to solve it.
Hmm.
And so why this works is like जितने भी numbers होंगे within R which have at least k multiples, right? Those numbers are ऐसे consecutive. Say one.
So let's just take an example of.
And if you have 1, 2, 3, 4, 5, you just
20.
need to remove whatever is less than L. That's it.
Let's take example of 10 through 100 and multiples. Let's take 3. So 100 by 3 is 33. Obviously, so there are basically 33 numbers from 1 through 33 which have these multiples.
1 से 33 everything will have 3 multiples.
Yes.
But अभी मेरे को सिर्फ 10 से बड़े numbers चाहिए तो इसलिए 1 2 3 4 5 6 7 8 9 को निकाल दूंगा. That's why I'm removing. That's why I'm removing L minus 1.
Yes. Understood?
That's O of one solution.
Hello. Any doubts?
Yeah.
Omic Sam. Okay. Nice. Coming to B. Now, what was B? B wasn't. Oh, wow. Okay. So in B, you are given 2 binary strings, 1 0 1 0 0 0 1 1, something like this, and the other has just one less length. What you are allowed to do is you can select any 2 letter 2 indices which are not equal, 2 consecutive indices obviously, which are not equal, and replace them with the ith character on the ith move. Now this is what you have to continuously do, right? Throughout, you can replace the ith character. You have to do n minus 1 moves. Basically, the size of this string moves. The number of moves is equal to the size of this string. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the number of moves is equal to the size of this string. And I have to replace these 2 consecutive values with this value of the ith value, R. For n minus 1 moves and if I can complete n minus 1 moves, I win. So I just need to tell if I can win or lose. That's the question. So you can think of this string as let's say I have a binary string. I have 0 0 0 and I have a few ones like this. You can think of it as if I get a 1 over here, right? I just have this option 0 1, right? I'll have to cut the 0 if I get a 1 over here, right? And then I get new values that can be paired. If I get a 0, now these two are there. I have to cut this one. So same thing applies on this side also. You can assume, right? I have a 1 and 0. I just cut. If I get a 0, I could have cut this one. So for every 0, you remove a 1, and for every 1, you remove a 0. In R, for every 1 in R, you remove a 0 in S. For every 0 in R, you remove a 1 in S. That is what you have to do. Just simulate this thing and check if and now if you can't remove anything, basically you reach a 0, uh, then just break it and print a no. So that's what I'm doing over here. I'm calculating the ones in S and zeros in S. If I get a 1 in an R, then I'm subtracting a 0 in S. You subtract the 0 in S. Else you subtract the 1 in S. If anything at any point before doing the operation becomes a 0, that is a no. Straight up no. So that's just it. Understood? This problem B. Hello. Hello, hello, hello.
This is.
Okay.
But I
Understood.
have a doubt.
Ha ha.
Does brute force work in this one?
Mm-hmm.
Manually
Manually?
raise kya the strings like I went erasing zeros and ones in the string.
You can do that.
You can stop. No?
That is what I am doing exactly.
But you are subtracting by count. No, I am manually deleting zeros and one.
Ha.
Finding zero one, one zero.
So if you get a 1, you would remove this 0, right?
Yes.
So that means your 0 count decreased by a 1.
Uh,
It's
but
a,
I am going to the zero and deleting the zero bar.
so won't
Throughout the
that be
string.
n squared? Or you keep the 0 in mind that you want to delete?
Uh,
Huh?
I think really I know.
Oh,
And
TLE,
so
na?
the
That would go n squared, right? Like if you go to the 0, oh, I am at this 0 and I will delete. Stuff like that. And yes, exactly. I am at this 0 and I delete. So
I can
that
tell you
will
I am
obviously give a TLE.
no,
La-
thora ye to TL currently.
huh. Or are you keeping the smallest 0 next to a 1?
नहीं इसका TL.
Oh, that is TLE, na? Then sort. Because that will give you a
If you
TLE
want
if
to
you
look at
iterate.
the removal thing,
Huh.
I could have done with stacks instead of points. Like
Show.
easier.
Show, please.
My phone can code it.
I will see code now. Don't worry. Where is my friend?
Just
Arre? Where is destroyer? Oh, destroyer solved so fast. Arre?
yes. After that, I've done.
Arre? Arre, where is? Either. Yes. Where is this? Oh, using stacks. Nice. Oh, so you can do it in O of 1. Ah. O of 1 in the sense, oh, okay. Understood.
Two and
No TLE.
आपका सोल्यूशन क्या था विरम भैया? बट डिस्कनेक्ट हो गया.
My solution was like inserting a 1 is like removing a 0 from the main string, and inserting a 0 and like processing a 0 is like removing a 1 from the main string. So you just keep on doing that.
whatever I can remove, till my hours are there.
Yeah, I
And
am
just go
going
ahead.
straight, if I would like to say, as per the question at least.
Yeah.
Like, I see. But opposite
I
to
can
you.
just explain my solution to people if you want.
Explain, explain.
Yeah. Cool,
Wait.
cool.
Uh, boom, boom. I should have solved C earlier.
Yes.
Though.
So, firstly, if you have a continuous stick of ones, we can't do anything to it. We just keep pushing them to the stack, right? So that is my first condition. If my stack is empty or my stack cutoff is equal to my current character, keep pushing.
Hmm.
Now, like since we found a zero, all of them were ones, and now my next character is a zero. I remove the first one, like topmost one, right? Now, when I'm removing the topmost one, I'm adding the R0 or R1, whatever is left, right? For the whatever is the first thingy I'm adding, literally brute force. So when I'm adding that, I see if that forms a 1-0 or 0-1. If it does, I pop the latest element once again and I increment the index. And
Yes.
at the end, when everything is done, I push my current R of ind because that is left, right? I'm removing two things. I have to push one more. That's what I'm doing. And at the end, my stack size should be one.
Yes. It has to be one. Yes, correct. Okay.
I took 10 minutes because I didn't do in the last condition. If wait, not this.
If what? Hmm.
Very stupid. Okay?
Huh.
In the last end less than I didn't do in plus plus.
Yes.
I did in end only and I was like, where is it going? Where is it going?
Oh, I see.
Debug for 10 minutes and then did plus and got it.
I see. So do in plus plus inside. Na? Wow. Don't do this magic. Don't do. Write in plus
I
plus
know.
like this. Alag se.
I know.
Wow. Ha.
I was like frustrated
Anyways,
on that.
coming to see. So in problem C, I am given an array, and I what I can do is, and I have to maintain a rating graph some of sorts. I can skip a few contests and I can continue. I have to skip at least one contest, right? So what is the max rating I can achieve? Now, one thing is for sure, whatever whatever you skip, right? Let's say I want to start a new thing from here. Like I want to skip 100% this thing. So there was a rating of 0 here. There was some x1 rating here. There was some x2 rating here. There was an x3 rating here. And there was some x4 rating here. Right. Now I want to pick this thing. Like I don't want this 0. Like okay, sorry, I am skipping this index. I could increase ahead, I could also increase ahead, I could also go here. But what is the best skip that I have? It is always the highest value of these things, of all of my values. So if this was a 0, this was a 1, this was 2, this was 1, this was 1 again, it was 1 again, it will be 2. I will skip this whole thing. Now why is that so? Why is taking the higher rating always a good thing? This is because uh, imagine this: you have a rating which is let's say some x rating, and you have another rating which is x plus some y rating, where y is a positive integer. So if you get some value which is between x and y is going to go down and x is going to go up, right? But it will never be such that they will cross. Why is that so? So let's assume I get a value x plus y minus 1. So I'll come to an x plus 1, and here I'll go to x plus y minus 1, right? So they will come to the same rating, but they won't cross it. Just assume this to be 15, this to be 14, and this to be 16. They won't cross it. They are never going to cross. And assume if this was 15 also, then also this is going to come to 15, this is going to go to 14. So these, whatever the rating, if I start with a higher rating and I go down, it is never going to be less than if I had started with a lower rating. This everyone understood, that I always want to transition from the higher rating. Correct? This everyone understood? Hello? Hello? Please, yes, no? Yes. Okay. Now, I always want to transition from a higher rating, that is established. So we can use dynamic programming over here to get to our solution. So what are we doing? What is my state? My dp of I denotes the min, sorry, denotes the value max value max value, no, but max rating, you can say max rating after a skip, after skip. Okay, so this is my dp of I. This denotes my max rating after a skip. So now what are my transitions going to be at index I? So my dp of I could be, and let's say f of x r comma perf. So rating comma perf, what does this function do? This function tells me that if I currently have this rating and in the contest I give this performance, what will my new rating be? What will my new rating be? Right? So I can take the one that I had not skipped, the previous one which I had skipped, right? It can be uh, f of I, that we have established before, that we always want the max value, right? So we take maximum of dpi minus 1. What is dpi minus 1? I have already skipped it. Or my max value before index I minus 2, I am skipping, comma, my performance at this point. So this is the transition, and you output at the end, you output dp of n, max value of dp of n, comma, maximum of n minus 2, because n minus 2, no, n minus 1, yeah, max of n minus 1. Why n minus 1? Because I can just skip the last element also. So yes.
Wait, what?
So
Why are you just going two backwards?
huh?
Why are you just going too backwards?
Two backwards. Two backwards is I am skipping one element. Na? This thing, na, you are
Skipping
asking.
the one before, right?
Ha, not the one before. I am taking the max of all of these. I could have taken from here also. It's the max element,
Okay.
prefix max.
Fair, son. Got it.
Understood?
मैं मेरा
Reflect
बाइनरी
me.
सर्च एक्सप्लेन करूँ क्या?
Ha. Please stream. But this is DP. But just a minute.
I think मेरा भी kind of though like ऐसे check.
Wait. Just a minute.
Maybe
Anyone doubts in the DP solution? Then we move on to the new solution. Any doubts? Let me just explain the code. Then you start off with the binary one. Yes. Anyone doubts? Sam, Omik, Rajdeep, Adit. No. Okay. Now, if you don't know dynamic programming, you just have to implement this transition that we have currently made. You solve as many more problems as possible. Just try to visualize it in an array. Let's just take the second test case. What was this? Not the second test case, like 998 test case. 998. I think it was a 2, 3, 4, 3, 5, 3. Yes, I think this was a test case. Sorry. I should have copy pasted. Sorry. Uh, 982 44353. 244353. 2, but doesn't matter, right? Okay. Yes, this was the test case. So, what we are supposed to do? Let's have a max element and our DP array, right? So my initially it is a 0. Both are zeros. Max has to be a 1 here and max will be 2 here. I am skipping the first element because like I can't literally take the first. I can't skip anything here. So this will be infinity, you can say, like a value that probably can't come, and I'll be a 1 here. I'll have a 1 here. So going ahead, uh, so now going ahead, what is my max? Let's just simulate this. 2, 3, 4, 3, 4, and 3 over here. So coming ahead, I have a 1 over here. So yeah, okay. So the max value over here will be 3, and what I can do is I have skipped a one already. I skipped this already. I could have taken from here or I could have taken from here. So anyways, it's going to be 2. Same thing, I could have taken this or this max value that I have skipped, right? So I took the 2, and after that I'll get a 2, and the max value is still a 3. I am maintaining a prefix max, but let's assume we are at a 2. I have a 3 and a 2. I could have taken this 2, or I could have skipped and taken this 3. I'll obviously take this 3 and go to the 4, and over here, what am I going to have? I'll have a 3 if I went normally. Now same here, I won't take the 2, but I'll take the 3 because I can skip this whole thing also, right? So that is why we take max values, and after the 4, but I'll take the 4 only. I'll have a 4 and I'll have a 4 here. Same thing going ahead. I'll definitely have a 3 here, and this will be a 3. And over here, I'm going to get, I'll have a 4 and I'll go to a 5. So I'll get the 5. Like I have a 3 or a 4. So I take this 4 and skip. So same thing here, and I have a 4. So 5, 3. I'll obviously take the 5 and move down to 4. So what skip did I make? I made this skip. If you just observe it, like, yeah, like here, this is like I did not skip. I did not skip. I skipped literally, and on this 4, I did not skip. I did not skip. I skipped, and I did not skip. Yes. So this is how you can have those transitions. Now just coming to the code, we initialize the values. I have initialized the values for 0, 1, and 2, and we start with the 3. As I did here also, I had initialized the values for 0, 1, and 2. And yeah, this is the value that I'll be processing for the DP, max of prefix max and DP. I'm processing the normal X, which is maintaining this array and getting the max of it till now. And this is my DP, which I'm processing the value. Like I'm making the transition from here or from here, basically. And I'm just, for safety, I'm going through all the prefix maxes. What it could be said, right? I reach the 4 and then I just don't go ahead. Very much possible. So I'm doing that too. So that is my solution. And now, Nishant, please move on with your binary search solution. Also, if
So
any doubts,
in your solution,
uh,
go to a solution. That's correct.
X calendar,
Let's say the square box you draw, that is your DP max whatever.
that is my prefix max. I am not storing my max in DP. DP of I denotes
I don't know when you're calculating the final answer. You're taking max of every single thing, no?
For prefix max. So I'll be taking a 4 here. So it's basically saying that I'll just skip this whole segment.
That time.
Yes, that is what.
Okay, fair enough. Okay.
Understood, na? So Nishant, please move on with this solution.
हाँ एक्चुअली अभी मुझे लग रहा है कि मेरा भी थोड़ा डीपी ही है बट नहीं ठीक है ऐसा बोलते नहीं है ठीक है तो बेसिकली मेरे सोल्यूशन में भी स्टार्ट ऑफ द सेम ही हो रहा है मेरे पास अगर कुछ नंबर्स है ओके आई जस्ट नीड टू बाइनरी सर्च फ्रॉम 0 to k कि व्हाट स्कोर इज पॉसिबल ओके सो फॉर अ स्कोर टू बी पॉसिबल ठीक a score being possible एक तो monotonic होगा like अगर k possible है then all numbers less than it will also be possible because you can just skip any one increment and if you just skip that one increment then you will achieve the score of k minus 1
skip one
तो
increment
ये monotonic
meaning?
तो है like अगर पहले increment होता है फिर increment होता है फिर decrement होता है then increment होता है तो अगर आपको k minus 1 अगर ये k achieve करने का है ये वाला then k minus 1 अचीव करने के लिए कोई भी एक इंक्रीमेंट को आप स्किप कर सकते हो
Oh, so I skipped this increment and that is why I could not go through this decrement.
Yeah. तो then तो इसलिए तो वो मोनोटोनिक हो जाता है
कि not
अगर
always.
k पॉसिबल है तो k minus 1 भी पॉसिबल है k minus 2 भी पॉसिबल है
like if I skip the second decrement, like my value reaches 100 assume and my decrement is like my performance is 1 now, right? So I have 0 through 100, so my value now reaches 100. I have a 1, so if I skip the 100th value, I will from 99 also I'll still decrement, right? But you are saying
but
I won't.
I'm just saying अगर k possible है तो फिर k minus 1 भी possible होगा okay रुक जाओ I think अगर मैं वैसा ड्रॉ
करूंगा you are saying that way okay if k is possible k minus 1 is also possible
like,
okay understood
let's say ऐसे जा रहा है ठीक है and k अगर possible है then just stop here ना खत्म k minus 1 भी possible
understood oh if k is possible k minus 1 is also possible okay
हाँ, तो दिस इज जस्ट कि मोनोटोनिक होना चाहिए उसके लिए,
हाँ
ठीक
हाँ
है.
हाँ.
तो नाउ वी कैन जस्ट बाइनरी सर्च 0
On
से
the
n पे.
answer.
हाँ.
On your
So
answer.
on the answer, yeah, on the
Yes.
answer. So now how do I check whether some middle element m, ठीक है, we need to check whether this m is possible as a score. तो how I am checking that is, ये पूरा उड़ा देता है. हाँ, तो समझो ये मेरा array है, ठीक है. अभी मुझे एंड में आफ्टर ऑल द थिंग्स मेरे को रेटिंग में m चाहिए, ठीक है. अभी एक एग्जांपल लेंगे तो ये बेटर समझता है कि लेट्स से आई वांट माय फाइनल स्कोर टू बी 4, ठीक है, एंड यहाँ पे द लास्ट एलिमेंट इज 6. देन कैन समवन टेल मी कि व्हाट इज द स्मॉलेस्ट एलिमेंट, लाइक व्हाट इज द स्मॉलेस्ट स्कोर जो मतलब 6 पे पास होने के बाद इट विल बिकम 4, लाइक ऐसा.
So
लाइक अगर अगर स्कोर लेट्स से यहाँ पे आते हुए द स्कोर वाज 3 एंड 6 इज ग्रेटर देन 3, तो +1 हो जाएगा, तो 4, राइट.
yes.
But and then the other cases, अगर यहाँ पे we had a 2 instead,
हाँ.
then you
I
need a
required a
5
5.
here.
Yes.
Yeah. So it is either this +1 or this -1.
हाँ.
Okay. So I just repeat this process. Like अभी 5 will become the new previous element, and अभी
हाँ.
I'll try to achieve 5 from here. तो अगर यहाँ पे 3 है तो मेरे को 5 अचीव करना है, तो मेरे को एक क्या चाहिए रहेगा, 6 चाहिए रहेगा,
हाँ. Okay.
right?
So
So I just keep doing this and I store all of this stuff in a suffix minimum array, ठीक है. Like तो यहाँ पे actually the value stored will be 5. ये 6 मैं बस अलग से ऐसे store कर ले रहा हूँ, but the actual value is 5 suffix minimum में.
हाँ.
What this is doing is, now in the next iteration I'll start from the first, and first से मैं बस पहले तो 0 से चालू करूँगा एंड मैं नॉर्मली इंक्रीमेंट डिक्रीमेंट जो भी है करते रहूँगा, एंड एट एवरी इंडेक्स आई विल चेक अगर द सफिक्स मिनिमम ऑफ i+1,
हाँ.
ठीक है, i+1 का सफिक्स मिनिमम अगर इट इज लेस देन इक्वल टू व्हाटएवर द स्कोर इज हियर, देन इट मींस कि आई कैन अचीव दिस फाइनल स्कोर. In that case I'll return true, नहीं तो false. That's it. The check is
Okay.
really easy. सोचने में टाइम गया बस.
Why the suffix
समझा आपको?
minimum? हाँ, मतलब my issue was
तो
कि
like so the suffix minimum is storing की अगर एक इंडेक्स है i, okay,
हाँ.
then what is the minimum score that you need such that अगर मैं किसी भी एक इंडेक्स ग्रेटर देन i पे स्टार्ट करूंगा ना, I can then reach k, I can then reach m.
Oh,
Like what is
okay,
the minimum
okay,
score so that I
okay,
can reach m.
okay,
समझ रहे
understood.
हो?
That's why
हाँ.
you'll have a suffix. Okay, understood. Okay.
हाँ.
Anyone
So
doubts?
then I can just greedily build this. I
हाँ
mean
हाँ
normal ऐसे brute force वाला build this and then check कि मेरे पास उससे less than
हाँ.
equal to m है क्या.
Anyone doubts over here?
समझा सबको कि बाइनरी सर्च क्या कर रहा है?
The check function and binary search.
आपका गोड फंक्शन वापस समझा
कौन सा फंक्शन?
मतलब जो
Check.
फंक्शन, हाँ वही.
हाँ राजा. तो एक तो सफिक्स मिनिमम है, ठीक है. ये मिनिमम में मैं क्या स्टोर कर रहा हूँ ना, इसकी अगर कोई इंडेक्स है i, तो व्हाट इज द मिनिमम स्कोर, ठीक है, कि अगर मैं ये स्कोर के साथ i या फिर i से बड़े कोई भी इंडेक्स पे, i या फिर i से बड़े किसी भी इंडेक्स पे अगर मैं चालू करूंगा, देन आई कैन रीच m. तो ये वाले एग्जांपल में जैसे देखा, ये पूरा उड़ा देता. क्वेश्चन का ये एग्जांपल लेना है क्या? इधर गया. अरे रुक जा. हाँ, तो लेट्स से मेरे पास है 4 है, 3 है, फिर 5 है, राइट. ये मेरा 2 1 कुछ भी रख देता. हाँ, एंड अभी मैं तुझसे पूछ रहा हूँ कि मेरे को अचीव करना है एक स्कोर ऑफ कितना अचीव कर सकते हैं इधर, 3 अचीव करना है मेरे को, ठीक है. तो अभी अगर मुझे 3 अचीव करना है एंड में, फिर मेरे को सबसे पहले तो इधर एक 2 चाहिए रहेगा, क्योंकि अगर 2 है तो 4 ग्रेटर देन 2, तो 2 + 1 3, इसलिए इधर एक 2 चाहिए रहेगा। अभी अगर मुझे इधर एक 2 चाहिए तो फिर ये 3 में मुझे एक 1 चाहिए रहेगा, क्योंकि 3 ग्रेटर देन 1, 1 + 1 2। तो अगर इधर एक 1 है, फिर इधर 5 में
Zero.
फिर एज लॉन्ग एज आई हैव अ 0, फिर ये भी 0 हो जाएगा, ये भी 0 हो जाएगा। तो बेसिकली तू समझ जाना कि ये अचीवेबल है अगर मैं या तो 3 पे 1 के साथ आऊँ, या फिर 4 पे 2 के साथ आऊँ, या फिर 5 पे 0 के साथ आऊँ, या फिर 2 पे 0 के साथ आऊँ, वैसा ना
Yeah.
कि मतलब इस सफिक्स मिनिमम क्या है, समझा दे।
हाँ समझा।
नहीं, but
चेक करके
now if you come with a 0 at 1, you can't like how will you build a 3 over here? You get a 1 1 2 1 2 3 3, like
Yeah.
how will you get the 3 over here? Oh, once you get the 3 you just break. Okay, fair. But
Okay. Once I get the 3, it's just equal to just deleting the rest of it.
ah,
Yeah.
but if you come to 5 with a 0, but what if you come to 5 with a huge value like 10? Oh, then it's better than 3. Okay, so you put a true. Oh, damn, nice.
वो क्यों ना ऑफिशियल अकाउंट से दिया आज
हाँ,
Rated था वो भी।
yes.
भाई गिर गया
But minus one.
Gorish has become
CM.
strong.
नहीं पर वो अपने ऑल्ट से दे देता है क्या?
ना
गलती से दिया क्या रेट?
ना
गलती से दिया क्या मेन से?
अरे नहीं, he was just ऐसे.
Don't be
He
alt.
just doesn't want to be a pussy anymore.
Yes.
ओ अच्छा।
Don't give from alt.
स्ट्रीम हो रहा है शायद से ये।
शायद नहीं,
निशु का
100%
प्लस
yes.
63 तब ऑलमोस्ट सबका प्लस लगा है मोस्ट ऑफ लोगों का।
Now coming to D.
मेरा minus है.
तेरा
D
प्लस
isn't that hard in my opinion. People just listen D.
हाँ, okay.
Shouldn't have you read D?
D I also have an approach.
Okay, you have read. I have an approach. I'll just share. You have a graph in D, and what you have to do is you can select any 3 nodes, and what you can do is that if the graph has 0 edges or
Light
has
से बोल जाते.
huh okay, you select any 3 nodes and the edges between all pairs of nodes. If an edge exists, you remove it. If an edge exists, you remove it. If an edge does not exist, you add it. Okay, so this is what you have to do, and you have to make the graph cool. So what is a cool graph? A cool graph is a tree, either a tree, right, a single tree, or a graph with 0 edges, right, graph with 0 edges. Okay, so and how many times can you do this? You can do this 2 into max, and max of n comma m, where n represents the nodes and m represents the edges. So if you say 2, so that is it, and you need to build a tree or make the number of edges 0. Now the thing to notice is, if I don't have a cycle in the graph is already a tree, right? Like it's not already a tree, there are a few components here and there. So what we can do is, so let's just see how can we build a tree in the graph. So I have a few empty nodes, right? Sorry, I'll just query any 3 nodes I have queried over here. We build it. Now the previous node of these 3, 2 nodes will be the ones that I had queried, and the third node will be a new one. So I'll have this edge and this edge, and the previous node that I had queried, the edge will be removed. Now one of the 2 nodes that I had previously queried, right? So let's say it's one of these 2 I have queried before. So I'll have this, sorry, let's just take these 2. I'll have this edge and this edge, and we can just cut off this edge. So same thing, we can just go ahead and get a tree like this, if I'm not wrong. Sorry.
Our method will give us cycle.
This and this
But currently what you're doing will give a cycle.
will give a
You need
cycle.
to start, you need to start from an edge, not a empty node.
I need to start from a node with some edges, you are saying.
You need to start from any edge.
Sorry.
And then you
Sorry.
can
Sorry. My bad. Shit. So I have something like this. And then I query 3. Sorry. My bad. And then I query any 3. And we just move forward. So basically, if you have an empty graph, it is possible to make a tree in O of n time. Correct? Is what I mean to say. Hello. That is correct.
disconnected graph.
That is just
without
merge.
cycle.
Right. Disconnected without graph. I have 0 edges in the graph. So I can make in O of n.
No, 0 edges you can never
0
make.
edges,
Zero
sorry.
edges, that's
Like
why-
one edge at least.
that's why 0 edges.
One edge at least. My bad. One edge at least. So I can just have this thing. This thing could have had a lot of edges, right? And this is literally like all of these nodes represent this. Like the root node is this. So the representation for all of these nodes just goes here. So I can just, this also might have a few more nodes, very much possible, but all of these are represented by this single node. So that is how we can just make this graph in O of n time.
मुझे merge वाला logic समझा, लेकिन cycle breaking मुझे समझ ही नहीं आता कि implement कैसे होगा वो cycle को break
So now we
करना.
need to break cycles. If I have something of, let's say, size 5, right?
Yeah.
So if I take these two, I can get an edge here, right?
Yeah.
Now I can do the same thing and take these two, and I can erase these two edges, and I have this cycle. These are standalone nodes now, and I have this cycle, and now we can just go with this thing, if I'm not wrong.
No, now you just remove all the edges.
नहीं, now अच्छा,
sorry.
if the whole
I
graph is a
remove all
cycle
the
वैसे तो
edges.
it ends up being empty.
Sorry. Now I just remove all the edges, right? So
There is a problem in this.
what? So cycle, if a cycle of size greater than 3 exists, it can be decomposed, but there is small issues still, right? If there are 2 cycles that have a common edge, so something like this, and I have a common edge here and a common edge here. Now what do I do?
ऐसे फर्क नहीं, minute.
Right.
Process one and then check for the other. If there is a still, if it's a cycle.
So exactly, you can just remove. So there is no need to remove this common edge. What you have to do is remove one of these edges on the sides, because
No, you can remove the common edge.
no, if I remove the common edge, it still remains a cycle. Like imagine,
नहीं, not really.
Where is the triangle? You just remove it.
अरे remove
पूरा
this.
triangle choose
हाँ,
कर दो
पूरा
ना.
triangle remove ना, but
Remove the
if
entire
I
cycle. that's it.
take this and this edge is what I'm saying. So imagine this was not a triangle, na baba. Just take it this way.
Yeah, whatever cycle it is, you can decompose it to empty thing. No.
So here I won't remove the common edge, right? I can't. I'll remove.
No, you remove the entire cycle.
I'll remove the entire cycle. Correct है.
तो इसमें
But-
common जुड़ जाएगा ना?
हाँ?
तो इसमें common जुड़ जाएगा.
हाँ. But
While you remove this.
oh, सही बात. Oh, sorry. My bad. Shit, what was I thinking? Why was I going in this direction? Yes, you are
No,
correct.
this all I implemented. This is not an issue.
Aha, so what is an issue now? You remove the common
Five,
elements. So like
like, mostly as cycles कैसे निकाला है?
cycles, it is single DFS. You can get
No,
all
no, okay.
cycles.
अभी think of a 5 nodes fully connected graph.
Uh-huh. 5 not strongly connected,
5
like
node
fully
fully
connected.
connected component.
Oh, okay. Boom. One, two, three, one and two. What else is left? This. Fully connected. Now,
One edge is multiple edge वो निकाल दो.
oh, sorry.
Yeah, now the problem is your DFS.
Hmm. I can, like, you can get literally all the cycles. It can be done in O of n plus m, basically. And your number
I
of
don't know. It is the number of the cycles. It is a faulty.
is
It gets you simple cycles, not the complex ones.
simple cycle only. What is the number of cycles? Hello. What is the number of cycles, sir?
हाँ cycles are तो निकाल लेंगे. I coded it. Check my code.
Oh, Nikalo. Wow. Wait. Let me go. Let me use my magic. Chat GPT. Give
I
me
don't know. It's
to
not
get
that cycles. Check the code वाला cycles.
what code wala cycles?
अरे वो GFG में मिल जाएगा. Definitely. Number of cycles. All the
Sort
cycles.
in graph. Wait, we'll do
अरे
GFG
check
also.
my code ना. I have submitted it.
Oh, I have
Yeah.
searched it.
I did पूरा implementation.
Oh, you did implementation. There can be fault
Yeah,
there, is
पूरा
what I'm
implement
saying.
कर लिया. Got WA. There is a problem. I'll tell you. And you realize.
So copy. Now we go online GDB. Oh, what is the issue?
अरे when you decompose two simple cycles, no,
Huh?
it makes a complex cycle, and that complex cycle is not detected by the algorithm we use.
Oh,
So
not all cycles are
yes, like
detected.
it. No, no, no. A complex cycle is not detected, and when you remove two simple cycles, you might create another simple cycle. That's it.
Ah, what? Why is online GTP not loading? Mute. Online GDP. Or I will have to use this useless thing. Practice. Oh, sequel on Codeshare. Magic.
Path to 5 stars खोलो भैया.
Huh? Path to 5 stars.
हाँ.
Okay. See, this is path to 5 stars. Boom. So
अरे check my code ना. I've done पूरा implementation.
अरे पूरा implementation. अरे I am making graph. अरे
हाँ
major
graph
issue is it
सब कुछ किया हमने.
my issue is कि yeah, because this is tried and अरे किधर Wow, code for. Oh, damn.
I cross-checked with GFG also to confirm.
Don't know. Reach. Oh, this guy solved. Wow. So many
केवल
people
जैन
solved.
gave GM perf या कुछ तो.
Oh, GM per. This is GM per. Oh,
No,
this
945
person
is not
solved.
GM.
Damn, this guy master now. Damn. This person is reaching master. Easy. I should have solved D. Where is D stroke? Where is issue
Not the
coming?
latest one. Not the latest one. Second one.
Wow. So इसके लिए I am saying ना कि take from GFG. Now I will have to
Second
search
week. I took from GFG.
per
Copy, like, I checked it with you. Proper, what the
find cycles. Okay, vector cycles. Okay.
My process query, process cycle is also good.
We check both. Oh, ADJ. अरे यार. Uh, हाँ, correct. This is Jenny. Yes. Oh wow, magics. There is add edges function. Wow, magic.
I made it later because it was late. Didn't use it.
So, uh, 5 edges and 20. No, 10, right? Sorry. 1,
1, 2, 1, 3, 1, 4, 1, 5. 2, 3, 2, 4, 2, 5. 3, 4, 3, 5. 1, 2. 3, 4, 3, 5.
uh, 1, 2, 3.
This time.
10. Uh,
As different problem.
I rank 945 is only CM perf.
what?
Yeah, it is.
Hashtag define int LL.
What do you expect?
Wow.
Array has
Template
defined
आ गया.
LL long. Right? What are you doing?
Oh. What?
I don't
Oh.
think you can place a semicolon.
Conflicting? What?
There are two colors.
Wow.
Both of them are conflicting. Array just print to alag se, no?
C. C. Oh, wow. Wow. P. P. CN. 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 Boom. Green cycles. Oh, sorry. CN. Uh-oh. 2, 2, 3. No. 1, 2, 1, 3. Sorry. 1, 4, 1, 5. That is not possible. 2, 3, 2, 4, 2, 5. 3, 4, 3, 5, 4, 5. 4. 141 to 150. Correct. 10. What? This should not be possible. Why is this so? Why only 6 cycles? One. Let's count. One, 2, 3. One, 2, 3, 4, 5, 6, 7. Oh, lot of cycles. Ah, lot of cycles. It's not detected. Is the problem? Cut this. But what if you write cycle detection without coloring? Like simple DFS? Or this again? So boom, boom, boom.
हेलो गाइस, मैं आईपीसीवी पास करने के प्रयत्न के लिए जाता हूँ. बाय.
Bye bye.
गुड नाइट.
Is printing all the cycles? Will it, like literally all the cycles? Will printing all the cycles give a W, like TLE? Huh? Hello, Janil. Wait, the stream over. I think this